Hello and welcome. This instructional video is a first step towards understanding the Garmin GNS 400W and 500W series units and the WAAS system. The main focus of this instructional video is to help you understand the benefits of the WAAS system and to describe some of the operational differences between the classic GNS 400-500 series units and the WAAS-capable GNS 400W-500W series units. Let's get started. What is WAAS? WAAS stands for Wide Area Augmentation System. In the next few minutes, we would like to take the opportunity to provide you with additional information about WAAS and what the Garmin GNS series units can do to enhance navigation within the National Airspace System. WAAS is a very precise navigation system for aviation, which provides the additional accuracy, availability, continuity, and integrity necessary to enable pilots to rely on the global positioning system for all phases of flight. Pilots today can use GPS for many flight operations. However, to fully meet all navigation needs, GPS must be augmented to provide better availability of the signal and to provide usable vertical guidance. WAAS provides this augmentation. WAAS significantly improves safety by providing near-precision approach capability at almost all runway ends in the National Airspace System. WAAS provides differential correction, integrity information, as well as vertical guidance on the approach phases of flight. This enables the system to provide a level of safety that has been unavailable until now. In July of 2003, the Wide Area Augmentation System was commissioned by the FAA over most of the continental United States, adjacent oceanic regions, and much of Alaska. WAAS is one of the satellite-based augmentation systems certified for instrument flight. When WAAS became available, aviation users were able to use WAAS as a navigation aid for en route, LNAV, and VNAV approaches. There are over 1,000 LNAV-VNAV approaches developed and published to allow pilots to safely descend to 350 feet above the runway threshold with the vertical guidance provided by WAAS. In September of 2003, the first of the near precision approaches, known as LPV, became available, providing vertical guidance to a decision altitude of 250 feet. As of November 2006, there have been over 600 LPV procedures published. In 2003, the CNX-80, later renamed the GNS 480, became the first WAAS-certified TSO C146A GPS aviation navigation system. In 2006, the Garmin GNS 400-500 series units received approval for the WAAS upgrade. This upgrade certified new and existing units with upgrades to TSO C146A, renaming them GNS 400W and 500W. The WAAS upgrade to TSO C146A gives the GNS 400W and 500W units LNAV-VNAV and LPV approach capability. The G1000 integrated avionics system also received TSO C146A WAAS certification in 2006. Let's talk about the structure of the WAAS system. A network of 25 WAAS ground stations located throughout the United States monitor GPS signals and relay data to two master ground stations. In turn, they assess signal validity, compute corrections, and create the WAAS message. The message is then sent to a ground uplink station for relay to two geostationary satellites over the equator. The corrected differential message is then broadcast through two WAAS satellites to WAAS-enabled GPS receivers. There are two objectives to WAAS. First, it provides differential corrections. Corrections to atmospheric effects on the GPS positioning signal are broadcast from the two geosynchronous WAAS satellites, improving GPS position accuracy to less than 3 meters horizontally and vertically. Second, it provides integrity information and alarms. The WAAS-certified GPS navigation system will alert the user of problems with the GPS system within 6 to 8 seconds of detection. Non-WAAS units take up to 15 minutes before the user is notified of a problem with the GPS system. Let's quickly review the WAAS structure. An aircraft equipped with a WAAS GPS receiver collects GPS signals and acquires position. 25 ground stations collect GPS signal data. Collected data is sent to the two WAAS master stations where the ionosphere correction values are calculated. The WAAS messages and corrections are sent to a ground uplink station. Ionosphere correction values are transmitted to WAAS satellites. WAAS satellites broadcast correction values to be used by WAAS-capable TSO C146A GPS receivers. WAAS GPS receivers take ionosphere correction values to improve position accuracy. WAAS coverage is only available in the United States. To receive WAAS position corrections, there must be a ground station providing data from that particular area. Even though users can receive a WAAS signal from outside of the United States, the signal only provides differential correction for locations in the United States. Other countries are developing their own satellite-based augmentation systems similar to WAAS. In Asia, it's the Japanese Multifunctional Satellite Augmentation System, also known as MSAS. Europe has the Euro Geostationary Navigation Overlay Service, also known as EGNOS. With the non-WAAS GPS receiver, typical positional accuracy is approximately 15 meters or about 50 feet. With the WAAS GPS receiver, typical positional accuracy is less than 3 meters or approximately 10 feet or less. The WAAS GPS receiver calculates its position 5 times per second, while the non-WAAS GPS receiver calculates position once per second. This, together with the enhanced vertical accuracy and other system enhancements, allows for vertical approach guidance. With new technologies, integrity and capability of navigational equipment has increased significantly. Reception of ground-based navigation aids such as VOR and NDB are limited to line of sight as well as other interferences. With the introduction of GPS technology, the ability to navigate within the National Airspace System has increased. The addition of FDE, fault detection and exclusion, allows GPS to be used as the primary means of navigation in oceanic and remote airspace. With advanced WAAS technology, you can now use GPS as the primary means of navigation through the entire route of flight from takeoff to landing. Let's discuss the approach capabilities of the TSO C146A GPS WAAS unit. The approaches are categorized in 3 different levels. Gamma 1 or Class 1 category approaches are the traditional non-precision LNAV approach. Gamma 2 or Class 2 category approaches are the non-precision LNAV approaches with vertical guidance. Adding the advisory glide path to the current LNAV approach, LNAV plus V and LNAV VNAV approach. Gamma 3 or Class 3 category approaches are the GPS LPV approaches. The LPV, localizer precision with vertical guidance, provides ILS-like accuracy during GPS approach procedures. Here's an example of an instrument approach chart displaying a vertical profile to minimum descent altitude and decision altitude. Minimums are based on GPS navigation system performance. On this slide, every flag represents an airport that meets criteria that allows LPV approaches to be created. Information about LPV approaches at any airport can be obtained from the FAA website, www.faa.gov. Let's summarize the benefits of WAAS in the National Airspace System. The GPS can be used as a primary means of navigation from takeoff to landing. Precision GPS approaches are available at a variety of airports. The GPS system can be used as a replacement for decommissioned ground-based navigational aids. The GPS reduces and simplifies equipment on board the aircraft. Let's discuss some of the operational differences between the classic non-WAAS TSO C129A GNS series units and the WAAS TSO C146A GNS series unit. When looking at the units, the WAAS unit looks identical to the classic non-WAAS unit. Here is a classic GNS 530 unit. When you upgrade to the WAAS GNS 530W unit, it will look exactly like the classic non-WAAS unit. You will notice some improvements on the WAAS units. Here are some highlights of improvements. Glide path information is available for most GPS approaches. The 5 Hz GPS update rate makes the GNS 500W series arc view appear more fluid. The new processor allows for faster zooming and panning on the moving map page. WAAS-enabled units have the ability to provide guidance along curved flight paths to include procedure turns, holding patterns, and DME arcs with roll steering output to an autopilot. Terrain is shown at higher resolution. The improved weather data link interface provides more weather information products. There is an improved interface between 400W and 500W series units, which allows the GPS unit to be used as the XM music controller. It will be beneficial for users transitioning from classic non-WAAS GNS series units to the new WAAS units to review the GNS 400W, 500W Pilot's Guide. There is also a new manual titled, What's New with the 400W, 500W series. Both manuals can be downloaded from the Garmin website, www.garmin.com. In addition to the manuals, you can also download the WAAS GNS PC simulator from the Garmin website. Please review the Trainer User Guide for detailed operating instructions for the PC simulator. The approach enunciations are shown in the lower left corner of the display. Appropriate enunciations are shown for each type of approach, such as LNAV, LNAV plus V, and LPV. Review the Pilot's Guide for all of the enunciations provided by the WAAS units. Here is one example of an operational difference between classic GNS units and WAAS GNS units you should be aware of. In a typical scenario, air traffic control gives a heading assignment for vectors to final for an instrument approach. In this scenario, we will use a GPS runway 22 approach into McMinnville Municipal Airport at McMinnville, Oregon. Let's start with the aircraft located adjacent to the runway on the right downwind leg with an assigned heading for vectors to final. It will be necessary to program the GPS runway 22 approach by pressing the procedure key, selecting the approach with appropriate transition, and specify vectors to final. Once we have activated vectors to final, we notice the SUSP or Auto Suspend enunciation above the OBS or Omni Bearing Selector key. Auto Suspend is active for vectors to final until the aircraft position has moved to the to side of the final approach fix and the aircraft ground track is within 45 degrees of the published inbound course line. At this point, the Auto Suspend enunciation will automatically extinguish. It is important to understand that we do not need to press the OBS key to extinguish the Auto Suspend enunciation. Here is a scenario showing what happens when the OBS key is pressed while operating under vectors to final before crossing to the to side of the final approach fix. The classic TSO C129A GNS 530 is shown on the left, and the WAAS certified TSO C146A GNS 530W is shown on the right. We begin with the aircraft on an assigned heading with vectors to final activated in the flight plan. As shown previously, the green Auto Suspend enunciation appears above the OBS key. If the OBS key is pressed, the GNS 530W will return to the auto sequencing mode and activate the nearest flight plan leg. This becomes a problem for the operator as ATC has issued instructions to intercept the final approach course prior to the final approach waypoint. The operator has now learned that the GNS 530W will need to be returned to the auto suspend mode, and having previous knowledge from the operation of the classic GNS units, the operator presses the OBS key again, expecting it to return the GNS 530W to the auto suspend mode. Pressing the OBS key a second time activates the OBS mode from the missed approach waypoint rather than the auto suspend mode. A green OBS enunciation will appear above the OBS key. The message enunciation will flash, and the message "Approach not active" is displayed in the message window. From this point forward, pressing the OBS key will either activate a direct course to the missed approach waypoint or activate the OBS mode referencing the missed approach waypoint. The correct method to reactivate vectors to final and reactivate the auto suspend mode is to press the procedure key and select Activate Vectors to Final. The auto suspend enunciation will then reappear. To satisfy the requirements of TSO C146A, the auto-suspend enunciation must be displayed when vectors to final have been activated for an approach. It is important to remember that when vectors to final have been activated, it is not necessary to press the OBS key. It is better to allow the WAAS GNS unit to unsuspend automatically at the appropriate location. Here is another operational change made from the classic GNS units and the WAAS GNS units. In this scenario, we will demonstrate how the WAAS GNS unit can provide guidance through an approach hold and course reversal. In this scenario, we will continue to use the GPS runway 22 approach into McMinnville, Oregon. The aircraft is positioned so that it is about to cross the initial approach fix to enter a holding pattern as a course reversal. Again, the classic TSO C129A GNS 530 is shown on the left, and the WAAS TSO C146A GNS 530W is shown on the right. Prior to crossing the initial approach fix, the hold entry is displayed on the moving map. As the aircraft approaches the holding fix, the type of hold entry and entry instructions are displayed. When flying the classic GNS units, it would be necessary to put the autopilot into heading mode or hand fly the aircraft through the holding pattern. Roll steering guidance is now provided from the WAAS GNS units, allowing the autopilot to fly holding patterns and procedure turns. As the aircraft crosses the holding fix, the auto-suspend mode is enunciated above the OBS key in the classic GNS unit. The WAAS GNS unit will not go into the auto-suspend mode. The WAAS GNS unit will show turn instructions to the next active leg of the approach. When joining the inbound approach course with the classic GNS units, the auto-suspend enunciation will automatically extinguish. The GNS units will then provide guidance along the final approach course. Different from the classic GNS units, the WAAS GNS units will not display the auto-suspend enunciation. This allows the autopilot to navigate through all legs of the holding pattern, then sequence automatically to the next leg of the instrument approach. If the user wishes to continue holding instead of sequencing to the next leg of the approach, the OBS key can be pressed to reactivate the suspend mode. The message enunciation will flash, and the message "Approach is not active" will appear in the message window. The method for reactivating the suspend mode in the WAAS GNS unit is identical to the method used in the classic GNS unit. Press the OBS key. The message enunciation will flash, and the message "Approach is not active" will appear in the message window. When flying the classic GNS units, it would be necessary to put the autopilot into heading mode or hand fly the aircraft when on the outbound leg of a holding pattern. With the classic GNS unit, each additional turn in the holding pattern will result in the unit auto-sequencing to the next leg of the approach when joining the inbound course. The WAAS GNS unit, however, will remain in suspend mode until the OBS key is pressed again. Once you are cleared for the approach, you must press the OBS key on the WAAS GNS unit to cancel the suspend function and to activate the next leg of the approach. WAAS units will display different missed approach course sensitivity than the classic GNS units. When crossing the missed approach waypoint from the final approach course with both classic and WAAS units, the auto-suspend enunciation will appear above the OBS key. Pressing the OBS key in both units will activate the published missed approach procedure. Missed approach course sensitivity will differ between the WAAS and classic GNS units. The classic unit will provide 1 nautical mile sensitivity to the CDI and display a green TERM for terminal sensitivity on the lower left side of the display. The WAAS unit will provide 0.3 nautical mile sensitivity to the CDI and display a green MAPR annunciation for missed approach in the lower left side of the display. When the aircraft position nears the missed approach holding fix, the WAAS unit will display the hold entry and entry instructions. The WAAS unit will also provide roll steering guidance to allow the autopilot to fly the holding pattern. The classic GNS unit will require that the autopilot be set to heading mode, or the aircraft must be hand-flown in the holding pattern. This scenario will review the difference in OBS operation between classic GNS units and WAAS GNS units. We will again use the GPS runway 22 approach into McMinnville, Oregon, using the Newburgh VOR transition. The aircraft is currently flying direct to Newburgh VOR. Before reaching the VOR, ATC instructs you to hold southwest over the Newburgh VOR on the 225-degree radial. The inbound course of the hold is your current directed course to the VOR. To stop auto-sequencing, press the OBS key. Both the classic and WAAS GNS units will enter the OBS mode, which is enunciated by the green OBS above the OBS key. Prior to reaching the VOR for the hold, ATC amends the clearance with instructions to proceed with the GPS runway 22 approach. To begin auto-sequencing again in both the classic and WAAS GNS units, press the OBS key. In this next scenario, we will fly the same approach with both units holding on the opposite side of the Newburgh VOR. We proceed direct to Newburgh VOR from the southwest. Our new hold instructions from ATC are to hold northeast on the Newburgh VOR 045-degree radial. This time, the inbound course for the hold is the opposite direction you are approaching from. To stop auto-sequencing, press the OBS key. Both the classic and WAAS GNS units will enter the OBS mode, which is enunciated with the green OBS above the OBS key. We select the 045-degree radial with the CDI course selector. We also see the course selection depicted on the moving map display, showing us on the from side of the holding fix. Prior to reaching the VOR, ATC again amends the clearance to proceed with the GPS runway 22 approach from Newburgh VOR. To begin auto-sequencing through the approach, press the OBS key on both units. The flight plan will reactivate and auto-sequence from the Newburgh VOR. The WAAS unit will display the suspend annunciation above the OBS key until the aircraft reaches the to side of the selected inbound course. This suspend annunciation is a WAAS certification requirement. Pressing OBS will unsuspend flight plan sequencing and activate the next leg in the flight plan sequence. You can press the Direct To key and activate the leg to the Newburgh VOR if needed. The parallel track function has been added to the WAAS units. This function allows the user to create a parallel course offset from the flight plan course. Here are some key features of the parallel track function. The offset distance can be set from 1 to 99 nautical miles in 1 nautical mile increments. The offset can be left or right of the flight plan course. You must have an active flight plan. The parallel track will not be available with an active leg of an instrument approach. Editing or executing a flight plan, using the Direct To key, or loading an approach will deactivate the parallel track function. It is not possible to save the parallel track in the flight plan catalog. You can learn more about the parallel track function in your WAAS unit's pilot's guide. A flight plan must be activated in the WAAS unit to use the parallel track function. You will see the active flight plan leg in the flight plan page. Press the menu key and select Parallel Track from the submenu. Select the desired offset distance and direction. A magenta-colored P will be displayed next to the waypoints defining the parallel track leg. The moving map will display the offset parallel track. Dead reckoning is a process of continuing to navigate based on your last known position and speed after GPS reception has been lost while on an active flight plan. The dead reckoning mode is only an estimate and should not be used for navigation. In the dead reckoning mode, several display changes occur. The own ship icon color is changed to yellow. The to from flag is removed from the CDI. DR appears on the left side of the map. All external inputs dependent on GPS position are flagged. Terrain is not available. Traffic and storm scope information is not shown on the map page. The dead reckoning mode is only allowed in en route and oceanic modes. In terminal or approach mode, a no GPS position is displayed on the map. Terrain is shown at a higher resolution on a WAAS GNS unit in comparison to a classic GNS unit. The terrain function is now a standard feature with all WAAS GNS units. If the GDL69 or 69A is installed with the WAAS GNS unit, both textual and graphic data link weather provided by XM WeatherWorks can be displayed. The WAAS unit will display high-resolution X-Rad radar, precipitation type at the surface, temporary flight restrictions, textual and graphic METARs, and terminal aerodrome forecast. X-Rad radar will be displayed for the entire continental United States. To view X-Rad information in a distant location, activate the map cursor and move the cursor to the location of interest. Here is an example of how XM weather information will be depicted on the WAAS GNS unit. Just off your left wing, you see weather activity. Confirm it with an X-Rad image overlaid on your moving map page. You can easily obtain local METAR information in that area. Audio entertainment is available from XM satellite radio service when the GDL69A is installed and the service is activated. The WAAS unit will serve as the display and the controller for the XM radio. We hope this presentation has helped you learn about some of the differences and enhancements from the classic GNS units and the WAAS GNS 400W 500W series units. Manuals for the GNS 400W 500W series units can be downloaded from the Garmin website, www.garmin.com. If you have any questions, comments, or need technical assistance with the GNS series units, please contact Garmin Product Support at 1-800-800-1020.